Hey, today we want to talk about how to measure light. But before we do that, we have to distinguish between two kinds of light. Light produced by something, or luminous source, and light reflected off of something, or illuminated source. First, luminous source. The sun is a luminous source. It puts out its own light. Candles are luminous sources. They put out their own light. Light bulbs are luminous sources, whether they're old-fashioned incandescent bulbs or more modern LED bulbs. A luminous source is an object that produces and emits light. The other type of light is illuminated source. So the sun is a luminous source. Everything else in this picture is an illuminous source. That is, it's reflecting light produced by somewhere else or reflected. Remember, light that strikes a surface can be reflected, absorbed, or transmitted. When one light strikes illuminated objects, unless the objects are white, the object will absorb all of the colors that make up that white light except for one color, the color we say the object is. That color will be reflected. In this case, the white light is striking a green leaf. All the colors except for green are absorbed. The green is reflected, and we can say that the leaf is green. So this apple absorbs all the colors except red, which is reflected off the object. The apple is reflecting light and it's illuminated light. Illuminated objects are visible to us because they reflect light. So illuminated source, an object that is visible as a result of light reflecting off of it. To summarize, a luminous source is an object that produces and emits light. And illuminated objects are visible because they're reflecting light. This is for your notes. Pause if you need to. Now we can talk about measuring light, or photometry. Photo is Greek for light, and metry means to measure. There are 3 units for light in the metric system. The first is luminous intensity. Luminous intensity just sets up the base unit for the metric system, which is called the candela. Remember, the metric system has 7 base units. All others are derived from the 7. Candela is the last of the 7 that we've come across. Now you've learned them all. The candela is defined as a light produced by a spermaceti candle. The spermaceti candle is the candle made from the oil of the spermaceti whale. These poor creatures were almost hunted into extinction because their oil was highly valued. It was valued because it burned very clean, it burned very bright, and the oil didn't go rancid or spoil. When the metric system was set up, this was the standard for illumination. That's the last we need to deal with the candela because it's not used for anything else except for establishing that base unit. We'll look at 2 units, luminous intensity, which is used for luminous sources, and luminous flux, which is used for illuminated sources. So luminous flux is the rate of energy or power in the form of visible light that is emitted by a luminous source. Most luminous sources have an output that consists of a lot of infrared light. And this is not included in this measurement. The unit for luminous flux is a lumen, which is abbreviated lowercase m, lowercase l, lowercase m. So for example, a 100-watt incandescent light bulb has an output of roughly 1750 lumens. You're probably asking, well, why if it's luminous flux, why do we need a U unit for power? We already had watts. Again, most things, like the sun, put out a lot of infrared and ultraviolet light. And we don't want to include these because with the lumens, we just want to know how much visible light the object is putting on. The same is true for old-fashioned incandescent lights, which put out a lot of infrared. And infrared is heat. As you've probably come close to light bulbs, they put out a lot of heat. That's why they're considered inefficient, because they're appliances meant to put out light, and yet they're putting out a lot of heat also, so they're wasting energy in that regard. Let's recap. We learned that luminous intensity is just used to establish a base unit for the metric system, the candela, and then we don't have to deal with it again. Luminous flux is the light of a luminous source, and it's in lumens. Now we need to look at illuminance, the unit for reflected light, or light that shines on surfaces. All illuminated sources start with some luminous source. In this diagram, it's D in the center. The light expands outwards in imaginary spheres. Any surface the light strikes is some distance from the light source. That distance is the radius of this imaginary sphere. At this point, you should be thinking, wait, I've heard this before somewhere. Indeed you have. It's the inverse square law, which we have seen with gravity, with sound, with magnetic strength, and with electrical strength. Now we're dealing with it for illumination. And this is going to be part of your lab also for this section, this lesson. Since the illuminated spheres are getting bigger and bigger as they get further from the luminous source, the power must be spread out to those bigger and bigger spheres. The surface area of the sphere is given by the formula 4 pi r squared. So in these examples, where the first one, this is a distance 1 from the source, so our distance is, and our radius are the same. It's 1. In the r equals 2, that's our distance from the source. It's also the radius of the imaginary sphere. So the surface area of the sphere would be 4 pi r squared, which in this case is 2, so it's 2 squared. And finally, the last example here is the area is 4 pi r squared, and the r is 3, so it's 3 squared. Remember, the distance from the source and the radius of the sphere are the same. So illuminance, symbolized as capital E, is power in lumens divided by 4 pi r squared. The unit for illuminance is lux, and abbreviated lowercase l and lowercase x. 1 lux, is 1 lumen per square meter. Here, example of how it's used. The amount of light striking a surface 1 meter from a 100-watt light bulb, which is about 1750 lumens, is 35 lux. So our power in lumens is 750, and we are 1 meter away, so that's our radius of our imaginary sphere. So we take the 1750 lumens and we divide by that surface area of the sphere, 4 pi r squared, and we get 139 lux. You will be doing this in your lab.